this button, my recording will stop. Okay. I will record this video and then I will post it in YouTube and in the Ulearn. Okay. Okay, so continue. So this branch is connected from node B, and then you have a resistor connected to node C, and then you have another branch over here. Okay, and the last one from node B, you have a current source to C. Okay, so this is the circuit that you have to draw, the simplified one. Okay, so from this circuit, then only it is easier for you to determine the number of branches, nodes, and also loops. Okay, so over here you can see that you have 3 nodes. Okay, node A, node B, and also node C. So you have 3 nodes. Okay, branches, you have 5 branches, 1, 2, 3, 4, and 5. Okay, and lastly, how many loops? You have 1, 2, and 3. So you have 3 loops. Okay, so that's why you need to redraw this circuit. Okay, in order for you to answer this kind of questions. And then for the nodes, branches, and loops, we have 2 rules that you need to remember. Is that the first rule is that stated that if 2 or more elements, okay, over here you have 2 resistor. If 2 or more elements are in series and it will carry the same current if they exclusively share a single node. So if you have 2 elements like this connected in series, so the current that flows through R1 and the current that flows through R2 is the same. So I1 is equals to I2. The second rule stated that if 2 or more elements over here, you have 3 resistors connected in parallel and have the same voltage if they connected to the same 2 nodes. Okay, so if you look at here, this is actually like this. So if you redraw, we have something like this. So this is node A, this is node B. Okay, connected to the same 2 nodes. So if you have the elements that are connected in parallel like this, the voltage, okay, across the R1 here is the same as the voltage across R2, and is also the same as the voltage across R3. So these are the 2 rules that you need to remember. If you have elements connected in series, I1 is equals to I2. But if you have elements connected in parallel, so the voltage V1 is equals to voltage V2 equals to voltage V3. Okay. Okay, so now let's continue to subchapter 2.8, which is the Kirchhoff's Law. So this one is in this week notes. I've already uploaded the notes for this week in the Ulearn. So please go to week 3 notes. And then you have this one. Okay. Okay. So Kirchhoff's voltage law and also Kirchhoff current law, KVL and also KCL. So we will cover this one in week 3. So basically for this subchapter 2.8, it involves a lot of calculation. Okay, it involves a lot of calculation. So therefore my advice is that you need to do a lot of exercises. Okay, so maybe in this notes there's only a few examples, but in the tutorial I've just uploaded the tutorial just now. So there's a lot of questions, then you can do it by yourself. Okay, so what is Kirchhoff's law? over here is stated that the foundation of circuit analysis is the first one, defining equation for circuit elements, for example, Ohm's law. Okay, so the first law that we have is the Ohm's law. Remember the Ohm's law? Ohm's law is V is equals to I R. Okay, and then we have another two law, which is the Kirchhoff's current law and also Kirchhoff voltage law. So for the Ohm's law here, it tells how the voltage and the current within a circuit element are related. Okay, from this formula, it actually tells you how the voltage and current within a circuit elements are related. For the Kirchhoff's law, it tells you how the voltages and currents in different branches are related. Okay, in different branches are related. So these are the difference between the Ohm's law and also the Kirchhoff's law. So first, let's look at Kirchhoff current law, KCL. So over here, stated that Kirchhoff's current law states that the algebraic sum of the current entering a node or a closed boundary is equals to 0. Okay, so this is the formula. The sum of current entering a node is equals to 0. Okay, so if you look at this figure, basically you have one node. Okay, you have one node, and then you have 5 branches. 1, 2, 3, 4, 5. You have 5 branches. Okay, so based on the Kirchhoff current law, stated that the sum of current entering a node is equals to 0. So if you look at here from this figure, okay, so if the current flows in, the current is positive, but if the current flows out, then it is negative. Okay, take note, if the current flows in the nodes, through the nodes, then it is positive. If the current flows out, then it is negative. Okay, so from this figure, you can actually get the equation. So I1, this is positive, and then I3 plus I3 plus I4. Okay, I2 and also I5 is leaving the node, so it is negative. So minus I2 minus I5, and the answer should be 0 because the sum of current entering a node is 0. Okay, and then you can simplify this. You will get I1 plus I3 plus I4 is equals to I2 plus I5. Okay. So the rule of thumb is that, like I explained before, if the current entering a node, then it is negative. If the current leaving the node, then it is negative. Okay, then you can get the equation for the KCL. So this is the equation for the KCL. Okay, so now let's do this example. So you're given this figure. You have one node and 4 branches. The question asks you to calculate I. This is the I. Calculate the value for I. Okay, so if you do the KCL at node A, so I label this as A. So if you do KCL at node A, okay, so the equation for KCL, so the current that flows in is 4 plus I minus 5 minus 11. This is equals to 0. So 4 plus I is equals to this one, brings to the right. So this is 5 plus 11. So 5 plus 11 is 16. Okay. So I is equals to 16 minus 4. Then you will get 12 ampere. So the current I here is equals to 12 ampere. Okay. So this is very simple example, but actually this is just the basic concept. But actually in your test, the question is not as simple as this. Okay, you will be given a complete circuit. Okay. Next, this slide actually stated that if you have a current source connected in parallel, you can actually simplify this so that instead of using 3 current source like this, you can just use 1 current source. Okay, so but you need to calculate for the I total. Okay, so this one, if you simplify this circuit, you remember this is a single node because there is no other elements. So I name this as node A. This one is a single node. This is B. This is A. This is B. This is A. Okay. So if you redraw, you will get something like this. Okay. So this is node A. Connected to node B. This one, you have a current source. Okay. This is the I total. Okay. Over here, this is I1. This is I2. This is I3. Okay, so from this circuit, you can get this equation using the KCL. Okay, so this one flows in. So I1 plus I3 minus IT plus minus I2 equals to 0. So you will get this equation. Okay, so I total is actually IS. So instead of using 3 current source, now you can just use 1 current source with the value of I1 minus I2 plus I3. Okay. Okay, so next let's do this problem, practice problem 2.7. So if you have the book, Sadiko book, you can refer to page 42. Okay, so if you have this book, I don't know whether you can see it. So this book, okay, so you can refer to page 42. Okay. Okay, so remember, if you have a questions like this, you are given a circuit, my advice is that you need to redraw the circuit. Okay, but if you don't want to redraw the circuit but still you can solve it, then it's okay. Okay, but if it's hard for you to solve it like this, my advice is that you redraw the circuit. So the first step here, first redraw the circuit. Okay, so in order to redraw the circuit, you must label the nodes. Okay, so if you look at here, this is actually a single node. And this is another nodes. Okay. So I label this as node A, this one as node B. Okay. So if I redraw this, okay, so this is node A, and then this is node B. So first I want to draw this branch. So from node A, there's a 2 ohm resistor. And then this one, you have current source. And then this branch, you have also this one is dependent current source. And last one, you have a 8 ohm resistor. So this is 2, this is 8. Okay, this is I naught over 4. This is I naught. And this 6 ampere. Okay. So after you redraw, now you can do the KCL. Okay. So if you do KCL at node A, so this is node A, you need to determine the direction of the current. So in this questions, you already given the direction of I naught or I0 over here. So the direction of current for this 6 ampere is like this. It follows the current source. For this one is like this. Okay. And the last one here, okay. Remember, current flows positive to negative. Okay, over here, positive to negative. So your current flowing through the 8 ohm is like this. Okay. So this one, for example, I label this as Ix. So now let's do the KCL at node A. So the current here is 6 ampere. So it is positive because it flows in the node. So we have 6. This one, this is I naught minus I naught minus I naught over 4 minus Ix. Okay, so the KCL said sum of current is equals to 0. Okay, and then you solve this one. So this one will become I naught plus I naught over 4 plus Ix is equals to 6. Okay. So over here, you know that I naught is equals to V naught over 2. Why I naught is equals to V naught over 2? Because remember the rules in the previous slide, it stated that if the elements is connected in parallel like this, then the voltage across these elements is the same. So basically, because you have a V naught here, so basically the voltage that flows through 2 ohm over here is also V naught. Okay. So you know that V equals to IR. So that's why I naught is equals to V naught over 2. And then Ix is V naught divided by 8. Okay. So you put this equation into this equation. So you will get V naught over 2 plus V0 over 2 multiply with 1 over 4 because you have I0 over 4 here plus Ix is V0 over 8. So this one is equals to 6. Okay. Simplify this, you will get V0 over 2 plus this is V0 over 8 plus V0 over 8 is equals to 6. Then you have V0 1 over 2 plus 1 over 8 plus 1 over 8 is actually equals to 6. Okay, and then this is actually you calculate for this one. So you have V0 multiply with 0.75 is equals to 6. So V0 is equals to 6 divided by 0.75 and you will get 8 volt. Okay, so this is V0, 8 volt. Now you need to calculate for I0. So I0, you know that I0 is V0 divided by 2. So 8 divided by 2. So you will get 4 ampere. Okay. So any question for this example, this practice problem 2.7? No questions? No. Okay. So no question. Then we can proceed to KVL. Okay, because there is no questions, then we can proceed to Kirchhoff voltage law. This is Kirchhoff current law. So Kirchhoff voltage law states that the algebraic sum of all voltages around a closed loop is equals to 0. Okay, you have questions? Saya kurang faham withdraw the circuit. Okay. So one of your friends said that he doesn't understand how to redraw this circuit. Okay, so let me do it again. So this one, okay, to redraw the circuit, you must make sure that you know how many number of nodes. Okay, so over here, this is actually a single node because there is no other elements. Okay, if for example you have a resistor here, this cannot be a single node. Okay, this can be a single node, but this one cannot be a single node. Okay. So this is a single node because there is no other element. It's basically connected at the same nodes. Okay. Same for this one. It is actually connected at the same nodes. Okay. So to redraw this, you have two nodes, node A, node B. It doesn't matter how you draw. It could be you want, if for example, you want to draw it like this. This is A, this is B. Also can. Okay, it depends on you. But this one, I draw it like this. So this is node A. So node A connected to 6 ampere source. So just redraw. And then this one connected to B. And then node A, this one, node A connected to a resistor. And then it connected to node B. And then we have another branch like this. connected to node B. This one, from node A, you have a resistor connected to node B. Okay. So this is actually the same. This is actually the same circuit. Okay. Because over here you don't have any other elements. So this one is actually a parallel. This is actually parallel. Okay. You can also do it like this. It doesn't matter. If you want to do it like this, also can. Okay. So any other question? If no questions, then we can proceed to the second Kirchhoff's law, which is Kirchhoff voltage law. So the Kirchhoff voltage law stated that the algebraic sum of all voltage just around a closed loop is zero. Okay. So this is the formula for KVL. It said that the sum of voltage in a loop is equals to zero. So for example, you have this circuit, okay, and this is your loop. You have a single loop. Okay. For KVL, the first thing that you need to do is that you need to know where is the current flow. Okay, the current direction. Okay, so for this one, remember, you need to remember current flows from positive to negative. Okay, so this one, this is positive, this is negative, so the current actually flows like this. This one, this is positive, this is negative, then the current is like this. This is positive, this is negative. This is negative, positive, so the current is like this. Okay, so this is your loop. Usually we draw the loops like this. Clockwise. Okay, clockwise. Okay, so you just follow the directions. Okay, so the direction of the loop is like this. Okay, so for this one, you can see that the direction is this one, the direction is counterclockwise. So this V is negative. Okay, so we said that negative V1. For this one, V2, okay, it follows the direction of the loop. So this is positive V2. V3 is also positive. V4, it is counterclockwise. So it is negative V4. This one, okay, this one is positive negative. So this is positive V5. So the sum of voltage in a loop is equals to 0. Okay, so this is the KVL equation for this circuit. Okay. So next, if you have a voltage source connected in series like this, you can actually simplify it. Instead of using 3 voltage source, you can use only 1 voltage source, Vs. Okay, but you need to determine the value Vs. Okay, so how to determine the value for Vs? Basically, okay, this is actually a closed loop. This is a closed loop. If you make the circuit closed loop, it will become like this. Okay. So first, remember I told you that you need to know the direction of current. So this is positive, negative, positive, negative, positive, negative. over here we have VAB, positive, negative. So this is actually like this, VAB. This is VAB. And then we have the loop. The loop is like this. So from this circuit, if you do the KVL, so the VAB is counterclockwise, so it is negative VAB plus V1 plus V2. Okay, sorry. This one is negative positive, so it is actually like this. This is negative, this is positive. Okay. So this is negative V3. So it's equals to 0. So VAB is equals to V1 plus V2 minus V3. So this is actually the VS. Okay. So now let's look at this example. You're given the circuit. The question asks you to calculate current I. Okay. Calculate the current that flows through the circuit. So this is a series circuit. So basically the current that flows in each component is the same. So this is the current I. Okay. So how to find the current I? So first, remember, determine the positive and negative. Okay. So this one, positive, negative. So this is like this. This positive, negative, positive, negative, positive, negative, and positive, negative. Okay. So you find the KVL equation. So this is counterclockwise. It is negative VA plus V1 plus VB plus V2 plus V plus V3. So the sum is equals to 0. Okay. So if you simplify this equation, you have VA minus VB equals to V1 plus V2 plus V3. Okay. So you know that this V is actually equal to IR. So V equals to IR1 plus IR2 plus IR3. This is Ohm's law. V equals to IR. Okay. Then you simplify this one. I multiply with R1 plus R2 plus R3. Now you can find the I. So I is actually equals to VA minus VB divided by R1 plus R2 plus R3. Okay, any questions? Because the value is not given, then the final answer is in equation form. Okay, because the question doesn't give you any value. But if the question gives you the value, then you need to find the value for the current. Okay, so basically you will get the same answer as this one. VA minus VB divided by R1 plus R2 plus R3. But this one is the in this slide it doesn't show you the step-by-step calculation. Okay. So this one is this is practice problem 2.5. So in Sadiku, you can refer to page 41. Okay. The question asks you to find V1 and V2 in the circuit of the following figure. So first, determine the current flow. This one is positive, negative, positive, negative, positive, negative, and positive, negative. Okay, and also you need to draw the loop. The loop here is I. Okay, so you do the KVL. This is counterclockwise, so it is negative 10 plus V1 minus 8 minus V2 equals to 0. Okay, and then negative 10 plus, you know that V equals to IR. So this V1 is I multiply with R1, this one minus 8 minus I multiply with R2. So this is equals to 0. Okay, so now you need to determine the V1 and V2 here. V1 and V2 here. So you know that V1 is, previously I said that it is R1. Okay, R1 is 4. So this is for I. V2 is R2. R2 is 8. So this is 8I. Okay, this is actually, no, sorry. R2 is this one, R2 is 2. So this is 2I. Negative. Why negative? Because the current flow is opposite direction. Negative 2I. Okay. So you cancel this one. So negative 10 plus V1. V1 is 4I minus 8 minus negative 2I is equals to 0. So you will get negative 10 plus 4I minus 8 plus 2I is equals to 0. Okay, and then 6I is equals to 10 plus 8. So you will get 18. So I is 18 divided by 6. So you will get 3 ampere. Okay. So the question asks V1 and V2. So you know that V1 is equals to I R1. So now you already have the value for I. So I is 3, R1 is 4. So this is 12. And V2, you know that V2 is IR2. I is 3, R2 is 2. So the answer is 6.
Madam,
Ya.
saya nak tanya, memang kena jadi 2 kali negatif ke?
Ya.
Oh, okey.
Okay, so the final answer is 12 volt and also 6 volt. So any question? No question? Okay. Then we can proceed to the next practice problem. practice problem 2.6. Okay, so this is in Sadiku, page 41. You are given this circuit, calculate Vx and V0. The first step, you need to draw the positive and negative, the current direction. Okay, this is positive, negative, positive, negative, positive, negative, positive, negative, and this is the loop clockwise. Okay, so you do the KVL. This is negative 35 plus Vx. So this is a dependent voltage source. So this is 2Vx. So plus 2Vx minus V0 is equals to 0. Okay. So you know that Vx is equals to IR. For example, this is IR. Vx is equals to IR1. Okay, for example, this is R1, this is R2. So R1 is 10, so basically Vx is equals to 10I. Okay, for the V out, it is IR2. So R2 is 5, so V out is equals to 5I. So this equation will become negative 35 plus 10I plus 2 Vx. Sorry, this is negative. Remember, don't forget the positive and negative, because this is the opposite direction. Then this is negative. Okay, don't forget the negative sign here. Okay, so plus 2 Vx minus negative 5I is equals to 0. So 35 plus 10I plus 2Vx plus 5I is equals to 0. Okay, and then negative 35 plus 35I is equals to 0. 35I is equals to 35. Then I is equals to 1. 1 ampere. Okay, simplify this. Calculate this. Okay, you will get current equals to 1 ampere. So the question asks you to calculate Vx and V0. So Vx is 10I. Vx is 10I. So basically 10 multiply with 1. So this is 10 volt. V0 is negative. V0 is negative 5I. Okay. So negative 5 multiply with 1, you will get negative 5. Okay, negative 5 volt. Any question?
Ma'am, can you repeat that again? I don't understand.
Repeat this.
Yeah, ma'am.
Okay. So if you have a circuit like this, For KVL, the first thing that you need to do, you need to determine the current direction. Remember, the current direction is positive to negative. Okay, and then you also need to draw the loop. This is the loop. This is actually the current I. Okay, the loop. The loop usually we draw clockwise. Okay. So this is positive, negative, positive, negative, positive, negative, and this is positive, negative. Okay. So first you need to find the KVL equation. So since this voltage here, the voltage source here, it is counterclockwise. Okay, the current is counterclockwise, then it is negative. Negative 35 plus Vx plus 2Vx plus V0, minus V0. This is counterclockwise. Minus V0 is equals to 0. Okay, and then this Vx here, this is Vx. You know that the Ohm's law V is equals to IR. So the voltage across this resistor is actually I multiplied with R. And the R, the resistor here is 10. So that's why Vx is equals to 10I. For the V0, okay, the voltage across the resistor 5 ohm is I multiplied with R. The R is actually 5. Okay, but since the current here is the opposite direction from the current flow, the actual current flow, this loop here, then it is negative. Okay, so negative 5I. So you put these two equations into this equation, you will get this equation. So the negative 35 plus Vx is 10I plus 2Vx minus again 5I is equals to 0. So the rest here is you just normal calculation. Okay, so negative 35 plus 10I plus 2Vx plus 5I equals to 0. Okay, so actually from this point to this point, there's other steps. Okay, I skipped that one. Okay, but basically later the final answer is I equals to 1 ampere. This one Vx, this is 10I. So okay, yeah, 10I. I forgot to change this one. This is 2 multiply with 10I. Then you will get this. Okay, so don't forget to change the Vx. Vx is 10I. Okay, so after you calculate, you find the current, then you can calculate for the Vx and also V0. Vx is this 10I. So 10 multiplied with I is 1 ampere, so you get 10 volt. V0 is negative 5I, so negative 5 multiplied with 1, you will get negative 5 volt. Okay. Any question? Okay. And then, okay, so we have last exercise for Kirchhoff's law, which is practice problem 2.8, page 43 inside the study group. Okay, so for this one, it's slightly different because you have two loops. Okay, the previous two questions you only have one loop. This one you have two loops. Okay, so in order to solve for this one, you need to use both KCL and also KVL. Okay, so now let's do this one. Practice problem 2.8. Okay, so first, draw the current flow. This is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. This is loop 1. This is loop 2. This is node A. I label this as node A. Okay. So the first thing that you need to do, you do a KCL at so the question asks you to calculate the current and voltage. Okay, the current and voltage. So the current, basically you need to calculate for I1, I3 and I2, and also V1, V2 and V3. Okay, so this is what the question actually wants you to find. I1, I2, I3, V1, V2 and V3. Okay, so when you do KCL at node A, this one become I1 equals to I2 plus I3. Okay. And you know that V is equals to IR. Then I is equals to V over R. So this I1 is actually V1 divided by, this is V1, this is this is V1 divided by R. The R is 2 is equals to I2. Okay, so I2 is equals to V2 divided by R. This is V2. So V2 divided by 8. The R is 8. Plus, this is I3. I3 is equals to V3 divided by R. And the R is 4. This is one equation. Okay. Now, let's do KVL at loop 1. This is loop 1, this is loop 2. KVL at loop 1. So this one is negative 5 plus V1 plus V2 equals to 0. So V1 is equals to 5 minus V2. This is the second equation. Next, you do a KVL at loop 2. Okay, so this one is negative V2 plus V3 minus 3 equals to 0. So V3 is equals to 3 plus V2. So this is equation 3. Now, what you need to do, okay, now because you have three parameter that you don't know the value, V1, V2 and V3. Okay, so now you substitute equation 2 and 3 into equation 1, this equation. Okay, so this is 5 minus V2 divided by 2 equals to V2 divided by 8 plus V3 is 3 plus V2. 3 plus V2 divided by 4. Okay. And then you just calculate and find V2. Cool. So this one is 5 divided by 2, you will get 2.5 minus, this is 1 divided by 2, so you will get 0.5 V2 is equals to 1.8, 1 divided by 8, you will get 0.125 V2 plus 3 divided by 4 is 0.75 plus 1 divided by 4, 0.25 V2. Okay. And then this is 2.5 minus 0.75. You will get 0.125 V2 plus 0.25 V2 plus 0.5 V2. Then this is 1.75 equals to 0.875 V2. So you can find V2. V2 you will get 2 volt. Okay. 1.75 divided by 0.875, you will get equals to 2. Okay, so now you already get the value for V2. Then only you can get the value for V1 and V3. So you already know that V1 is equals to, this is V1. V1 is 5 minus V2. 5 minus V2 is 2. So you will get 3 volt. So this is the answer for V1, 3 volt. For V3, this one is 3 plus V2. So 3 plus 2, you will get 5 volt. So the answer for V3 is 5 volt. Okay, any question? You get V1, V2 and also V3. But you still need to calculate for I1, I2 and also I3. Okay, so no question. So now let's calculate for I1, I2 and I3. So remember this value, V1 is 3 volt, V3 is 5 volt, V2 is 2 volt. So now let's calculate for I1. So I1 is equals to V1 over R. V1, we already calculate, the answer is 3. So 3 divided by R, the R here is 2. So 3 divided by 2 is 1.5 ampere. Okay. For I3, you know that I3 is V3 over R. V3 is equals to 5 volt. We already calculate this 5 volt. R is 4. For 5 divided by 4, you will get 1.25 ampere. Okay. So next for I2, you know that I1 is equals to I2 plus I3. Okay. So basically I2 is equals to I1 minus I3. I1 is 1.5 minus 1.25. So you will get 0.25 ampere. Okay, so this is the answer for I1, I2 and also I3. So any question?
Doktor, saya nak tengok KVL at L2 tu. Loop tu.
KVL at
Loop tu.
loop 2.
Ha. Yang kedua ni. Untuk cari V1, V2, V3.
Yang saya tunjuk tadi tu ke?
Ha.
Dia dah delete lah.
Tahu, dia delete lah.
Dia sebab saya pakai PowerPoint ni. So nanti awak boleh tengok balik video kot.
Okey, okey.
Okay. Okay, so any other question? Basically what you need to do, you need to find the equation for KCL, KVL and also equation for KCL. And then you need to find the equation for KVL at loop 1 and also KVL at loop 2. Okay, so from these three equations, okay, you just do calculation, mathematics, standard mathematics in order to solve for the unknown parameter. That's it. Okay. Any question? So basically for this kind of question, for KVL, for KCL, you really need to do a lot of exercises. Okay, so I've already uploaded the tutorial. I already uploaded the tutorial in week 3. Okay, go to your uLearn and I already uploaded the tutorial. Okay, so over here, I already write this. Please do the tutorial until question 13 because up until Kirchhoff's voltage law, you can answer the tutorial until question 13. Okay, but you don't need to submit it yet. Okay, you submit the tutorial after we have finished chapter 2. Okay, but my advice, please do after you finish one subchapter, then you can just directly do the tutorial, but don't submit it yet. Okay, so up until subchapter 2.8, you can answer the question 1 until question 13, this one. Okay, starting from this, starting here from here, this one will be covered in next week lecture. Okay, so please do tutorial question 1 until question 13. So if you have any problems, then we can discuss. Okay, only if you have any problems lah. Okay, so the final answer already given here. Okay, so if you don't get the correct answer, then you can ask me, then I will show you the calculation. Okay, just write in the paper. What do you mean just write in the paper? Okay, write in a, do the tutorial in a piece of paper, and then later on after you finish chapter 2, then I will put a link for you to submit it. Okay, so you just snap your tutorial answer and then use the cam scanner. Okay, then you upload it. Okay, after we finish chapter 2. Okay, handwritten, handwritten, because this is calculation. For tutorial 1, it's okay for you to type. But this one, because it's calculation, then you need to submit handwritten calculation. Okay. So actually, basically, we have finished the slide for this week. But my actual plan is that I wanted to continue 2.9 and 2.11 to. Is it okay if we continue 2.9 and 2.11? This one is in the week 4 lecture note. I just uploaded the lecture notes just now before the class. Is it okay that we continue 2.9 and 2.10, or do you want to have lecture next week? So next week, basically, we will have two sessions.
Next week
Okay, so it's okay. So then we will continue next week. But for next week, I think we need 2 sessions. Okay, because for next week, syllabus, okay, the content, I think we cannot finish in only one class. Okay, so maybe we will have class on next week. We will have class on Tuesday and also Thursday. And another thing, hari Khamis bila? Hari Khamis cuti. This Thursday is holiday. Okay. This Thursday is a public holiday. So we will continue our lecture next week. Okay, but next week we will have class on Tuesday and also Thursday. Okay, and another thing, okay, so if you refer to your teaching plan, your quiz should be in week 4, which is next week. Okay, so I need to set a date. So when do you want your quiz to be next week? Quiz 1. Weekend. Okay, weekend. Is it okay weekend? If we do it weekend, so weekend next week, maybe on Saturday. Okay, together with BEKG student, FKE students. Tak boleh? What tak boleh? Wang Kang Yu, why cannot on weekend? Weekend may not be at home. Then can we do it weekdays but at night? Okay, so we'll do weekdays at night. Okay, so I will share the time and the date later in the Telegram, because I need to confirm it again with the FKE students. Okay, so to quiz 1 will cover KCL, KVL, Kirchhoff's Law. Okay, so this today's lecture. So the quiz will cover this week lecture, which is the Kirchhoff's Law. Okay. So any more question? Yes, KCL, KVL. only KCL, KVL. No, it's basically similar to the example that we do just now, the KCL and KVL. Calculation, no theory, calculation. Okay, so no questions, then we can continue next week on Tuesday. Okay, so I already uploaded the slide for next week, series resistance and voltage divider, parallel resistance and current divider. So as a preparation for quiz 1, my advice is please do tutorial 1 up until question 1 until question 13. Okay, this one. Big 3, Big 3 is a tutorial 2. So this one, you have a lot of exercises for KCL and KVL. So please do this tutorial as a preparation for quiz 1. Okay, so this is KCL, this is KVL, KCL, KVL. Okay, until question 13. Okay, so if we don't have any more questions, then we can finish our class for today. Quiz answer also snap and upload. Probably. I haven't decided yet whether to give you objective or subjective, but most probably subjective question. Okay. So if you don't have any more questions, we can end our class for today. So thank you.
Thanks, Doctor.
Welcome.
Thank you, Doctor.
Thank you, Doctor.
Terima
Thank you,
kasih,
Doktor. Assalamualaikum.
Salam.
Thank you, Doctor.